This is Tesla's hairpin circuit with two Leyden jars. So that's Leyden jars over there. This here is the Tesla hairpin circuit with a really small spark gap. I don't know, it's probably a millimeter spark gap, and 15,000 volt transformer. And on this side is completely safe to handle. See, I'm touching the wires, the leads, no problem. It's not lit very brightly, but it's not going to electrocute you at all. So I thought that was kind of neat. With these capacitors are bypassed, so I connected the leads right to the other side of the homemade capacitor, and you get this effect. Reducing the size of the spark gap increases the frequency. Okay, I disconnected the hairpin side of the circuit, so I'm just running 15,000 volts through a graphite spark gap with strong magnets. I'm gonna see if the spark is gonna be deflected by the magnets. So here we go. As you can see, the spark is attracted to the magnets. I hope you can see this. Okay. Okay, this is an oscillating spark, so the current is moving backwards and forwards, and no matter which way I hold the magnet, it seems to be attracted towards the magnetic field. So let's see how this reacts when we connect a bridge rectifier to the circuit and turn it into a DC spark. Here I have a 15,000 volt transformer going to a bridge rectifier. Each one of these diodes is 30 kilovolt diodes, and here's the 30 kilovolt capacitor, 300 picofarads. And so I have the AC side hooked up to the transformer, the DC side connected to one side of the capacitor, and then the minus DC goes to the other side. And then I have the capacitor also hooked up to the spark gap, and the spark is quenched with a strong permanent magnet. So let's observe how the spark behaves. As you can see, the spark is pulled towards the magnet. Okay, now I flip the magnet, the permanent magnet. Let's watch how the spark reacts. I kept the magnet at the same orientation. I still have this capacitor here and this bridge rectifier. The only thing I changed was I added this Tesla's hairpin circuit to the to the spark gap. And my theory is the spark will no longer be affected by a magnetic field of a permanent magnet. So let's see how this goes. Here I flipped the magnets again with the Tesla hairpin circuit side connected. Again, my theory is that the spark gap will not be affected by the presence of the permanent magnet. So let's see if this holds true. To me, these series of experiments prove that Tesla's hairpin circuit changes the nature of electricity. It gets rid of the magnetic component, where your electricity is no longer is affected by a magnetic field. So you're keeping the electric component, but you're getting rid of the magnetic component. And I believe this is key to a lot of free energy technologies, including Stan Meyer's VIC circuit and others. And I'll continue investigating. I hope you guys enjoy.